a team play is following the naming convention, because it makes it easier for your colleagues to understand what you're doing. That's makes sense. And I think, yeah, I have run into different opinions, people that do stuff in a specific way, and somebody can be completely obsessed about, you need to have the curly brackets like this because otherwise I can't sleep at night, kind of obsession. I know I've worked together with people like that whenever they put a curly bracket, so they had to put a tab on the last curly bracket, so it had to be moved in. And whenever I give that guy some of my code, when I got it back, it was all of these curly brackets was just moved in, so he used a lot of time just doing, because he couldn't sleep at night if the curly brackets was on the same line. So you have a function starting here, and then you have the curly brackets either bang bang or bang bang. That depends. That's how I'm doing it. JavaScript is like this, C# is like this, but he had to do it like this. and he, so also when he was doing some teaching, whenever he did something he used a lot of time while he was showing people something to move that one, because none of the programming environments was doing that, because it's not common to have this the last curly brackets to be moved, the tab in, and of course he has arguments for that, but it doesn't matter, because you now have to follow the team. Yeah. Because otherwise, whenever you see that code, you will say, what the fuck is that? Where's the if starting and ending? Because it's just weird, because it's not like you're used to seeing it. So you have to follow this. The variables, you can use it with just a camel case, but it's also very common to see this underscore and then name. So underscore camel case for the field names inside C#. It's, I think, something they inherited from C++. They use that a lot. It's because, and I actually like, because I'm a C++ programmer. I've been that for 25 or 30 years or something like that. So moving into Java, all this dot, this dot, I hate that this dot, because it just, but I do it when I'm in the Java environment. I do it because that's how it's done there, because I have to follow the convention. But I just feel it's you just overload everything with this dot, and it's annoying. So one way to get around that is to say that the variables inside is called with an underscore. So in the constructor, when you get something in and you have to assign it to the internal representation, then what you have in the parameter is without the underscore, and so on. So that's just a convention. You don't have to follow that. But it's very common to do that in C#. So you will not see this used a lot in C#, because you don't need that, because you don't have the same name. And it's actually also very difficult when you start to learn people to program for the first time, and you have to do this dot name equal name. Wow. Try to get that if you haven't programmed at all. What the hell is going on here? You have two different levels of name here, and you can be a little bit confused. But anyway, they use this one here. Type case. Properties. Properties is without. It's not a function. It's a property. It's a special feature of C#. So you can make a property, and then you assign to it. You have to just have a property like this. So you can get the pi. If that you probably not assign to pi, because that's will be a constant or something like that. But the name, you can just get the name by just saying object.name, and you can assign to it by saying object.name equals something. And then behind the scene, C# will do get and setter like in Java. So you don't. So that's just a part of the environment, and makes it much easier to work with fields in C# than in Java. So you don't have to do all this get and setter kind of thing. So then we'll return to that. Classes are in title case. Interfaces are, for I don't know what reason, with an I. So I for interface. Come on, get into this millennium. I don't know why. Of course it makes sense, because sometimes it's a problem is you have an interface and you have an instantiation of that interface, and so what should be the name of the instantiation versus the interface? So they have made this choice that every interface starts with I. You can make an interface starting with anything. It's just the convention is that an interface starts with I. It gets a little bit weird when you have an interface starting with I by itself. So we have I, But anyway, that's the convention. So we have in the language value types, symbol types. Do you know about the stack and the heap? Yeah. So how many knows about the stack and the heap? Yeah, a couple of guys.
I just have to remember it again.
So what are we talking about? Do you have a clue what we are talking about when we are talking about the heap and the stack?
Oh yeah. Sure.
Yeah. So where are we in the computer? So what part of the computer are we referencing when we talk about the heap and the stack?
Memory.
Memory, yeah.
Yes.
Memory. We are in the memory. So the heap and the stack are memory. So the heap are where we can. That's the biggest part of the memory. So that's where you can whenever you do use new inside the language, you will actually get a piece of memory from the heap. But whenever you create an integer or a reference to an object, that will be created on a stack. So stack is a small piece of memory that is assigned to the program when the program executes. So the compiler knows, by compiling it, knows how much space do this program need in order to execute, to have. So it gets this memory from the beginning. That means that the application get this chunk of memory, and the application will use that to assign internal values to that. That's much faster than going to the heap, because whenever you go to the heap, you have to ask the operating system to get some memory from the heap, and then you get the heap memory and you can use that. That's fine. It's not like slow, but it's slower than using it inside because you have to allocate the memory. So you have to find some memory space in the memory, and then you have to deallocate the memory and free the memory again after using it. The stack is something that is assigned to the application when it starts running, and then it's allocated there, and it's deallocated when the application stops running. So so the application can do some smart stuff whenever you assign stuff to the when you need the memory in the stack, it's much faster to access that. Yeah.
Isn't the stack primarily something you combine with or you think about when you think about functions?
Yeah. So whenever you execute a function, you put it on the stack and you stack the information you need to.
Yeah. So you stack one function, next function. Yeah. When this last one is done its task and returns to the second one.
Yeah. So keep record of what is the state when you left this function, yeah, and make a call to another function. And when you return back, you need to have stored the state of that function. What are the values of all the variables you have inside that function? But it's just the idea of being faster to be on the stack than being on the heap. So that's the main point here. And value types are on the stack. So whenever you need whenever you need one integer is on the stack. Of course, if you need an array of integers, it will be mostly on the heap, but could also be on the stack. Depends on how smart your compiler is and stuff. So these are the simple types. So a Boolean. Yeah, something that you will see also in C# that they return to the real world of programming. So they have signed and unsigned integers. They didn't do that in Java because people probably be too difficult for people to understand that you have a signed and an unsigned. So everything was signed. So an integer in Java is always signed. But you can have unsigned integers. So what does it mean to be an unsigned integer? Yeah?
There's no plus or minus.
Yeah, there's no plus or minus. So it's actually, in order to have a signed integer, you need to have 1 bit to the sign. So if you have a 32-bit integer, you take away 1 bit for the sign. So that's the last bit is telling you if it's plus or minus, if it's 0 or 1. But that means that you in order to do that, you take away half of the size of the integer. Normally, an unsigned integer can have approximately 4 billion, is it? 4 gigabyte.
Yeah.
4 gigabyte. So that's the size. But if you have a signed integer, it can only be 2. So the highest number you can have is 2G, a little bit above that, but it's just. So that's the price. You use 1 bit, and the last bit gives you whenever you have 1 bit more, you double the size. That's the logic of binary numbers. So that's the price. It's not a big deal, but anyway, sometimes you don't need the signs, and then you can easily use the full space because you're not working with negative numbers, for instance. So that's the simple types, and then you have something called a struct and an enum. Struct is something that if you have done anything in C++, you know struct from, or C for that matter, you know struct from there. So these are all stuff that are living on the stack. So whenever you instantiate one of these guys, they'll be on the stack. So in order for the language to be able to work on different, in order for the environment to be able to work with different languages, what the language have to have in common is the types. Because otherwise you can't do something in Visual Basic and in C# and then use it together. There needs to be agree on the integer, on the Boolean type, and so on. So the system in the .NET have defined all the integers. So that's something called system.int32. That's a 32-bit integer, and that's part of .NET. And any language that are using an integer inside the .NET will use that one. Inside C#, it's just called an int. That's the default integer. So it's a reference to that 32-bit integer. So you have this reference, and also all the in something that is not part of Java is that all the value types are also objects. That means you can say int dot and then have functions, methods. You cannot do that in Java.
You have to write the full name.
What?
I think you have to write the full name.
No, you can just say int. Yeah. So if you can say int dot pass int or something like that. That's I can show that later. So you can also write integer 32 blah 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 if you want that, but you can use the. So it's an object. So a value type is an object. So it has some information about the max value and mean value and how to compare stuff and so on to string and so. So you don't have this. In Java they do it by having an integer with the capital letter. That's the integer object, and then you can move between the object integer to the